Thank you, Valentina. I'm glad to be here. And a big thank you to the Dartup team as well for having me. So, hello, everyone. I hope that everyone's having a great time at the conference so far. It's been a very insightful time, I'm sure, for everyone. And the last talk, I'm sure, have everyone on the edge of their seats waiting to be ready for developing some new chatbots. So, in this talk, I'm going to be talking about accessibility within Dart, particularly within developing Flutter apps. So, essentially, in this talk, I'll be talking about designing accessible distributed systems apps with Dart. So I'll be focusing on talking about how you're able to develop within distributed systems in particular, develop your apps based on distributed systems. So without further ado, let's get straight into it. So before we get into it, as Valentina has introduced as well, I'm going to introduce myself a bit as well. So as mentioned, founder and a developer of Advocate at GReS Studio. I'm a 12 times AWS, 2 times Azure certified, and 2 times Google's Cloud certified. My personal field of interest is within penetration testing and accessibility practices, as you can tell by the talk that I'm giving right now. I love advocating for better accessibility in terms of apps that people are developing. And on the side, I do fun stuff such as running meetups, hackathons, doing tech talks, and VR tech enthusiast. I'm a VR tech enthusiast as well. I've been doing tech talks for the past 4 years, and I've been very happy sharing my own experiences within the industry and also best practices about what you can do for accessibility, security, and many other topics. So, the table of contents for today. So in this talk, we'll firstly be going into the motivation, essentially understanding why we're having this talk right now, why accessibility is so important, especially during this time, and why do we want to strive for it. And secondly, we're going to talk about the backend architecture and our use case, which I'll go into a bit later. Third, the widget tree and semantics. So I'll be talking a bit about how you're able to utilize a widget tree and also utilize semantics to be able to create accessibility in this case scenario. Fourth, talking about how you're able to create accessibility tests for being able to test your particular app in this case scenario. And I'll be talking about in my particular given context. And fifth, what we managed to get out of it. And of course, from what we got out of it, what you can also get out of it as well. So let's understand the motivation a bit. Why is accessibility an even more important part of our lives today? And why does Dart play a big role in it? Well, firstly, of course, as many people already know, Flutter is a great platform to be able to develop web apps, applications on iOS, Android. And essentially, a big part of it is right now is the transition into more the usage of distributed systems. More and more people are starting to go into the concept of IoT, getting on the cloud, being able to utilize their services based on the cloud due to especially the current COVID-19 outbreak. More and more the businesses are transitioning their workloads online. More and more businesses, as a matter of fact, are starting to also put in their core services into distributed systems. Now, because of this transition, we see a greater need for accessibility because as more and more companies adopt a more distributed systems-based approach, we also need to be able to cater more towards accessibility for people who currently need it. And with the increasing need, we definitely will be able to continue seeing this need increase towards the future. And we need to be able to continue developing our apps to be able to accommodate that as well. And it's just a diagram, for example, showing how 4 Raspberry Pis are connected in one particular example to give results in one particular front end, for example. It's just an example of illustrating how distributed systems can function in this case scenario. So essentially, we need to be able to design apps as well that can cater towards this need. We need to be able to design apps that are able to provide better accessibility towards people who currently use the distributed systems at this current time. And that's what we're going to be talking about today. And of course, as I mentioned before, we have an evolution of IoT. And essentially in Dart, We have a increased use of it. Firstly, due to simplicity in design that Dart and also Flutter has in terms of being able to develop web apps and also applications in general. We're able to create an IoT hub for edge hardware. And I say this in meaning that we're able to create better IoT case scenarios in terms of being able to visualize them. And we're able to create them based on visualizing them on one device, based on one particular application, as that is one of the things that creating applications based on Dart is particularly capable of, especially when we leverage the power of the cloud as well to connect with Dart as well, in particular Flutter. And also, because Flutter, especially, is also designed to connect with databases, namely Google Cloud. And this helps to accelerate the development in IoT-based developments in a much better fashion, and hence accelerates the transition towards distributed systems in a much faster manner. And let's establish the context. So in this particular case scenario, I'll be giving this presentation based on an IoT-based alarm system. So this is a side project that I worked in the past as well. It's basically just showcasing how we are able to develop while considering putting into consideration different accessibility considerations. And in particular, I'll focus on adopting the guidelines from accessibility standards such as W3C and A11Y. If you're already following accessibility guidelines, I'm sure that those names should not be unfamiliar to you. So the World Wide Web Consortium and the Accessibility Project. So we'll be going into this as well in the next few slides. So let's start with a bad example. So you probably can already tell there are a few not so good aspects of this particular design when we talk about accessibility. So in this particular case scenario, you can already see that we have a very small text size, and of course, no text-to-speech option. And this is because text-to-speech option is always an important consideration when developing these particular applications, especially when we have fonts of very small sizes. And of course, the size of the button itself is not so particularly nice. So we're going to be going into how, for example, seeing this, how we improve it. And this is the front end that I'm using for a particular distributed system-based alarm application, alarm system. So essentially, we're just seeing how different alarms placed in different locations are triggered and how they are sent towards this app when they are triggered alongside the locations that they are at. And to get a bigger picture of the whole thing, I'm going to be talking a bit about the backend architecture. So I'm not going to be going into depth into this because talking about Google Cloud services is not the topic about this. Neither is the backend development. I'm just going to be describing each of these just briefly to get a better idea, to give you all a better idea as well about in case you are not too familiar with these services. So in this particular example, we're essentially having a receive and sending back message between the phone and Cloud IoT Core, which is essentially service to collect, manage, and ingest data from services. We then are able to send it from Cloud IoT Core to Google Cloud Pub Sub, which is essentially just a real-time messaging service that allows you to send and receive messages between applications. Then we're able to see that it's able to send data towards Google Cloud Functions and Google Cloud Dataflow. Dataflow is a streaming analytics service, and Google Cloud Functions is just essentially, as its name suggests, performing functions as executed by the data set by Cloud Pub Sub, and afterwards we can see them also then sending data towards Cloud IoT Core. That's based on the executed data, and afterwards we have Cloud Dataflow. We then send it to Cloud Bigtable, which is a NoSQL database for processing and analyzing workloads, and of course BigQuery as well, in order to manage serverless data in a particular data warehouse that allows us to do scalable analysis. And finally, use machine learning models from Google Cloud Data Lab to be able to provide analytics, learn analytics for us based on the analysis we developed in the machine learning. And of course, Data Studio for us to be able to create dashboards and reports. So there's this bigger picture into what happens in the backend architecture when we process and analyze and also work with alarm data. But I'm not going to be going too in-depth into that because we're not going to be covering backend as the topic of this particular talk. And essentially, one of the things I always bring up when I talk about accessibility is that clients are always number one. And that's what we always have to think about. Who are our clients? How can we cater our accessibility towards being able to really allow them to enjoy the most out of it? How can we help them to get the best experience out of it? And that is essentially the leading thing that will be rotating around this talk. When we build a widget tree, we should already start planning for accessibility. So when we plan our particular services, such as alarm system, which then goes into, for example, login screen, alarms page, home, and which alarm page then leading into, for example, alarm results and settings, we need to be able to think ahead when we build around this. We need to be able to think, how can we best build our the front end that will happen to this, our apps, to be able to get the best out of accessibility. For example, starting with login screen, how can we best design the considerations based on W3C considerations? Can we already start putting the buttons according to the suggested size? Can we start arranging our text according to the 16 points recommended size for web-based app developments? So all of this, we have to already take into account while we're developing our widgets. We should already consider how we want to be able to best structure this, as well as also consider which are the most important ones, so that we can also highlight the important ones and put them at the forefront of the user experience. Because for accessibility, putting ahead the most important parts of the application components is one of the recommendations that W3C has recommended, for example. And that's just something that I'm also going to talk about more in the next couple of slides. So when we talk about accessibility, semantics is always one of the important topics that come up as well. So in this particular example, we're using semantics basically to be able to create a better labeling of the data. So we create a label that essentially, for example, when we talk about the button before, for example, we had a reset data button. So in this particular example, we allowed that to have a label that says it's reset data. We label the button with reset data, and then we have a hint which can appear. It's to press to reset data flow, and we then just initialize the value of reset data, which we did initialize as an object beforehand, and of course create an on-tap object for it to be able to do the action, and of course have a child as well to display accordingly. So this will also help out later when we do the screen reading option from the app as a feature, so that it can read from semantics. And when we consider what W3C and 811Y guidelines, there are a lot of them to consider. And that's why when we go through this, we always try to be able to really take on the most important ones for our particular application. Most often when we develop as for accessibility, we don't have time to adhere to all of them because there's a long list of them. We try to adhere to the ones that really matter to us. So, and for example, in W3C, we have priority levels of support. We have A, AA, and AAA, for example, with A being essential and AA being and AAA being ideal support. So essentially, we want to be able to follow the ones that are related to our application, as well as the particular list that of A, for example, that is most likely needed for essential support. So some of the things that are to be taken into account when we build accessibility for applications is that some inbuilt semantics already exist. So when we do this, oftentimes when we start off semantics, we'll often come into collisions with other semantics that already exist. And in the end, we have repeating semantics. But we then can utilize exclude semantics, which I'll talk about as well in the next couple of slides to be able to prevent repeats from happening. So essentially, we're able to only have it occur once only. And also, performing a self-audit of the application is very important as well when we go through this. We're able to follow a self-audit by following the A11Y project accessibility checklist in this particular example. And one of the questions I also got before as well when I once talked about accessibility was regarding is this particularly for based on a web application, or is this particularly based on web browsers, or is this based on mobile applications? And the W3C and A11Y is mainly based on web browsers, but essentially it also focuses on mobile apps as well in some cases, particularly within the WCAG, the web guidelines of accessibility, essentially. So we want to be able to create better accessibility by following a particular checklist to be able to self-audit according to what we've already seen. And we want to be able to use W3C tools, in particular, if it's a web application, and follow through with the W3C guidelines, because W3C also provides tools to check if it's in the case if it's a web app containing HTML and CSS, to be able to check the accessibility of the current web app that's already developed, and also just check if it's already compatible and what needs to be still improved. So also structure web applications, and we need to be able to structure them in such a way so that we're able to see important content before scrolling, as I mentioned before. If possible, putting the important stuff at the top. For example, in this case scenario, when we're talking about alarms, we want to be able to put the important visuals on the top. We want to be able to put the important notifications, such as when there are alarms at the top, so that people don't have to actually scroll down first before they're able to see notifications. Because in such a critical application, it's important that we notify users that particular information directly instead of showing them options, not unnecessary options first, such as where your alarms are at. You need to be able to show which alarms have already gone off at what location, because those are the most important part of, for example, in this particular case scenario. And of course, we need to be able to reduce the input needed by text through providing buttons, checking boxes, etc. for input needed. And that's just an example of what can also be done in a particular case scenario of developing for alarms, this distributed alarm system. When we create this in particular, we need to be able to really provide as much user input that only checks for check boxes or buttons as necessary, because putting too much requests by input really puts a strain on the user experience, as well as also really making it hard for people who have more accessibility requirements compared to not. And of course, it's an example of excluding semantics, as seen here from what I've said before about excluding semantics from exclude semantics. And we're able to execute a particular action here. I'm not going to be going too in depth into this, as I don't want I don't mean for this to be a tutorial, because I already know that there are a lot of resources for coding semantics and excluding semantics online. So I just want to put this out as a highlight based on what can be done essentially for accessibility. And of course, we're able to also debug semantics as well through using show semantics debugger, essentially putting it to true. So when we do this, when we enable this particular widget, we're able to see highlights such as this. As we can see, our text is highlighted, our title is highlighted, our button is highlighted. So essentially, we're able to debug accessibility based on this. We're able to see the components based on this, and we're able to also make recommendations and fix up the particular components as necessary according to the debugger that we have seen over here when we have seen it highlighted. This is an example of how it's shown when we enable it. And of course, accessibility can never come complete without screen readers. When we test our accessibility applications, in this particular case scenario, we can always perform tests with talkback or voiceover as well, in iOS or Android respectively, Android or iOS respectively. And we want to be able to test if talkback, for example, can read it accordingly, because in accessibility, we always need to test for if the screen reader as well can read it out, because a lot of people who have accessibility requirements enable screen readers on their mobile phones as well. And as a matter of fact, they then will have to do this as well. So it's better that we directly just go for it as well and see how it goes in our own developments and ensure that it is ready for our particular users to use. Especially when we talk about alarms systems, we want it to be people to be able to be alerted directly. We want them to be able to get the message directly, reading out which alarms have already gone off at what location, and directly focusing on that data. And we're able to also use global and local context menus to be able to better allow the application to best provide the context necessary for users. So next up is also creating appropriate accessibility tests. So this is an example of setting up this accessibility test according to what was set up previously before as well. So we have setup all, for example, in here. We're using setup all to be able to set up our first register our function to be run once, essentially, before all the testing or starts happening. And we then start to do the testing itself. Just one particular example of validating that the reset button works. In this particular example, we can try finding the button label by the semantics label as we are labeled before, as it is reset data, and also get the ID and print the ID and expect the driver, in this case scenario, as from setup all to return us the semantics ID and the button label. And of course, also then test if the button is if the button can return the tapped action correctly when we tap on the button. And of course, when it's done, we then print out tap on button. And of course, color vision is a big part of accessibility in Flutter as well. We want to be able to ensure controls are legible when we do it in terms of colorblind and grayscale. And for Flutter, I've been playing around as well with this library for quite a long time now, quite some time. The cool color blindness package, and I recommend that everyone here will check it out as well. It's a great package to simulate color blindness. Essentially, in your apps, you're able to enable this particular package to be able to test out what it is like to be able to see a color your app in if you are a colorblind person. Because really, I don't think there's any better way to really develop an app rather than being able to experience the accessibility requirement yourself. And this will really help out in being able to develop for that. Of course, the W3C and A11Y already has a lot of guidelines regarding that as well. And of course, it's imperative in alarm systems due to the need for distinction in alert levels. And of course, we want to be able to create tests based on it. And for button layout, we can go with the usual flow of, we need to be able to design the usual flow for us to always ensure that we are able to execute our tests successfully. So the usual flow, for example, create a button, and then we have an action. We ensured each button has an action. We're then going to explain. We have an event to explain which control was just pushed, and we then test that the explanation and action is executed as expected. So this is the particular guideline of developing an accessibility to a particular button that can be used by many users in developing buttons for their accessibility applications. And just remember, users don't see your back end. They only see your front end. They only care about the experience, and that's why accessibility is all about the front end experience. And that's why accessibility never really comes from the back end. It's always focused on what you see, on what the user sees. As mentioned before, only display matters. So don't think about cloud. Don't think about anything else. You should think, when talking about accessibility, think about what your users are seeing, how you want them to experience it for accessibility. And of course, the code design patterns include following WAI, area design patterns. One of the examples is fall through with live regions, being able to essentially put dynamic content which updates without page reloads, and essentially enhance user experience on the side through this as well. This is an example of code implementing live regions in the particular region on the application. And just an example of how we want to be able to create a good color contrast for showing down servers in this particular application when we talk about color contrast. So what we got out of it, we got better client feedback. If we create accessibility for our web applications and applications in general, we get better practices for future groundwork. We want to be able to ensure that future people who work on our applications continue on to develop for accessibility, because accessibility is not only a practice, it's a culture. We need to be able to implement it directly into part of our culture, our working culture. We need to be able to make it standardized as a practice, and we need to be able to generate better analytics based on it. So wrapping up, it's simple to implement. Users will be able to appreciate the simplicity that you present to them. You're able to build onto the usability of your applications. Your clients will thank you for creating better design. You're able to also continually get feedback from clients throughout the usability development. And finally, you're able to build it as a pathway towards future development, set the groundwork essentially for future developments. And of course, as I mentioned before, your clients and everyone who experiences your application, especially since it's a distributed system, because they require it as part of their core applications, they'll thank you for it, and they'll be happy about it. And that's where I wrap up. Thank you. And I'm happy to take any questions. I think I'm running out of time, so I'm happy to take any questions if there's a bit of time now, or I'm happy to take it as well on the spatial chat application, or I'm happy to also answer it on Twitter, or it's LinkedIn as well, as I included as part of my details here. Thank you.
Okay,